Okay, hopefully it will work. So this, I should say, this is the first time I've actually looked at my thesis since quite a lot earlier this year. So I am ever so slightly not up to speed with it. And I've been speaking to very different audiences so far for, well, the entirety of this year. So hopefully I haven't forgotten all of the right ways of talking about this. But as Animesh mentioned, this has come out of my PhD thesis, which was called Safety, Security and Supply on the role of security in the development of the national grid. And it takes a rather broad sweep of time from 1914 up till 1956, looking at various different aspects of national security. Although that wasn't the original conception of the thesis, the original idea was to follow on from Graham's book and to particularly look at the issue of danger in terms of electricity and how electrical manufacturers and undertakers dealt with the idea of people being afraid of electricity. Very short space of time in the archives and the collections at the Science and Industry Museum actually found or demonstrated that this wasn't something they talked about. It didn't take too long to figure out why. If you want to tell someone, or if you feel the need to tell someone that your equipment is safe, you don't want to have to first of all explain to them why it's going to be a problem for them, which seems to have been one of the issues with this. So that very quickly got put onto a back burner. I think it's still an issue that needs to be looked at. It needs much more material cultures focus to delve into that properly, which I would have done, but my museum-based supervisor went on leave for the first year, so we weren't able to get into the objects too soon. But as I started reading through the archives there, it very quickly became apparent that the state had actually played a significant role in the development of electrical supply. And throughout the thesis, I show that the security of energy supply in particular was one of the primary motivations for this state interest. In fact, in terms of electricity supply, what they seem to, or energy, that what they're really interested in is coal for the most part, and electricity is simply seen as as the most efficient way of making use of coal throughout this period. So one of the first sections I looked at was this is where it's not playing for me. Was actually very quickly what electricity supply was like in Britain prior to World War I. As has been mentioned in a couple of other places today, it was a rather unhomogeneous system, I think is a good way of putting it. It's quite possible in a large city to move one street down and suddenly find that your electrical appliances don't work. There's no standardization, that you may be on DC at a certain voltage in one area and AC at a certain voltage in another area. And that was expressed a lot in the supply of appliances like the heater I've got up here, made by Ferranti around about 1914. And depending on the type of voltage and type of electricity you were using, the price could vary radically between £3.15 and about £8.11. So you can see it does cause a lot of problems, and I think these heaters, the heating element, which is the rather lovely spiral in the centre there, had a use of about a year before which it would need to be replaced. So this is going to be quite an expensive thing to do. There was already significant interest in interconnection and some fear of any one company being able to establish any form of monopoly. And of course, the gas interests, who at this point were using coal gas, were also well, definitely opposed the development of any single national form of electricity. So once we get into World War I, it's not long before the Ministry of Munitions in particular realizes that actually electricity is really important, and they very quickly take over control of electrical supply. So by the end of the war, you've got 95% of munitions factories receiving electrical power from generating stations, and the majority of the municipal or company-owned power stations were extended or built over the course of the war. So by the end of the war, there's a total of 327 municipal and 230 private companies involved in the supply of electricity, all coordinated through the Ministry of Munitions, who had encouraged interconnection between neighbouring power stations. So you see through this that the state, particular industrial production, had become increasingly reliant on electricity. And this was broadly supported by electrical engineers and manufacturers within Britain. And then I was surprised to discover there's quite a deal of support for this interconnection and standardization coming from the British Army. When I started looking into what was going on with electricity, it turns out that when the Expeditionary Force went to France in 1914, they took leftover equipment from the Boer War. And this was on a whole variety of different standards. At this point, it was essentially the same as electrical supply in Britain, in that the equipment was pretty much decided by their chief engineer based on his preferences and often contacts within the civilian industry at home to ensure supply. This caused all sorts of problems. Moving a unit a couple of miles down the front line might mean that any electrical equipment they had no longer worked and they'd need to switch over, or their engineers would need to learn entirely new systems of working. And as you can see from this, some of the main uses, again, mirror precisely the ways that electricity was being used on the home front. It was often for lighting. It was also used a lot in the communications areas for powering, for lighting, for hospitals, for equipment in dockyards, all sorts of different uses that essentially mirror what was going on at home. In 1919, at the end of the war, the General Headquarters France started working on a report on the uses of electricity and looking at the way that electricity had been used by different parts of the army in France. They came up with a whole range of different suggestions for this, or from their experiences, from having a look at what their allies have been doing. Particularly interesting to see their comparisons to the way American troops and British troops reacted. American troops were apparently safer around electricity because they were more familiar with having electricity in their homes and cities than most British soldiers were at this time. They also had a really good opportunity to have, as this map has here, a good look at the electrical systems being used in the German trench systems and compare those to the way it had been worked in Britain. And they were particularly struck by the standardization of all the different systems. They came up with a whole range of different ideas for how electricity should be developed for the British Army, as well as suggestions for how it should be developed more broadly within Britain. So they definitely recommended standardization, and they recommended standardization on AC power at, I think it was 250 volts. And it's interesting that a lot of the recommendations they make in this report go on to be picked up by the Central Electricity Board when it's formed, and eventually become part of the standards used for the national grid. Some of their other recommendations were that military engineers should be trained to run civilian power stations in the event of a general strike or a riot. Interestingly, that one never actually gets taken up. There's another one that they suggest that engineers should automatically be given military rank in any future war, partly to stop, as had happened in the First World War, to stop the munitions factories from nabbing the best engineers, partly so they would instantly come under military discipline in order to actually prevent them going on strike in the same way. There's another section of the report which becomes particularly important, on the use of overhead versus buried cables. And there are engineers, as was the case within the civilian sector, on both sides of this debate. There were some that supported DC electric power, some that supported AC, some that really loved buried cables, and others that preferred the overhead pylons. The pros for the buried cables was that they were theoretically safer from shell fire or any other form of accident. On the other hand, they're a lot harder to maintain because you've got to go and dig them up. Major Lockhart Jarvis, who was in charge of the electrical systems for the First Army, actually argued that high voltage AC power carried by overhead cable was both more reliable and economic in the use of manpower and fuel than other systems. And this seems to be the view that prevails within this report and within British Army engineers. But you get beyond this and the Army almost seems to lose interest in electricity. They've kind of got what they want. They've got standardization. They've got engineers trained in all forms of different systems they're likely to encounter. And actually, most of their operations weren't intended to take place in Britain. They didn't need to worry about it too much whilst in the country. Most army bases were supplied from local power supplies and didn't have their own generating plant. The same is not true for the Royal Navy. I'm trying to remember what I've got on the next slide. Oh, good, submarines. I'm tempted to say you can't have too many submarines. Apparently, some people disagree with me. The Navy is quite different in terms of the fact that every single ship they had was, in some respect, its own independent power station. And they were quite often used in that way. Most of the major naval bases also supplied their own electricity due to the high power demands of the equipment they were using. It's only very few bases, often slightly more inland supply depots, that relied on electricity from their local suppliers. The ability of naval vessels to supply power was shown twice, in both cases using submarines. In the first case, it was in 1926 during the general strike, and there was no power going to the food warehouses in London. So they submerged a couple of submarines and towed them into the Royal Albert docks and connected their diesel generators up to the warehouses to ensure that the food didn't go off. Although, as the paper at the time was very quick to point out, they've also got a rather big gun just to deter any rioters or people on strike from trying to interfere with this. The second time took place in 1947, so it's a bit of a leap. And in this particular case, it was called Operation Blackcurrant. It takes place during the severe winter of 1946-47. And between January and March 1947, they used 27 submarines to supply power to local coastal communities. Although it actually saves a grand total of 7,890 tons of coal, or approximately 10 minutes worth of coal mining. So no record of how much diesel they used in place of coal, although the Admiralty records note that it added approximately 29,000 hours to operational time for those submarines, and they then required 7 complete engine refits for them at a cost of about £161,000. So it was hardly a cost-effective or sustainable solution. And again, with the Navy, that's more or less all we see of them. Where it gets a bit more interesting is when we come onto the Royal Air Force. And they perhaps surprisingly, have the most significant part to play in the shape of the national grid as eventually formed. For the RAF, I've argued that this is actually essentially a political move. Throughout the early 1920s especially, the RAF is under considerable pressure from both the Army and the Navy, who want to regain control of their aviation resources. So for the RAF, this is kind of a fight for survival. So what they do round about the mid-1920s, 1924 is the first letter I found, is that they set themselves up as the experts on the defence and attack of power stations, and setting themselves up in such a way that this task could not be readily assumed by either the Army or the Navy, even if they did recover control of their aircraft. Throughout the period, they maintained files on European power stations. Although, as we get to see in the Second World War, it turns out that power stations are quite hard to significantly damage or disable using the aircraft and bombing technology available at the time. They also took an increasing interest in the development of the pylon network. Helps if I go onto this slide as well. So we have here, particularly in the top right-hand corner, they're diagrams of several major power plants, just showing sizes and how small the target area is to attack to actually cause any significant damage, as well as their suggestions on how to defend a plant or how to protect against shrapnel damage, and the interior, I believe, of Fulham Power Station after it was bombed in 1940 to show the type of damage that could occur. Although in this case, within 6 months, the power station was actually fully operational again. So even severe damage like this, it was not able to put a plant out of operation for very long. So in terms of the pylons, the RAF had interest in the shape of the national grid for several reasons. The first of which is that the RAF had become increasingly dependent on the railway networks for the transfer of engine parts, fuel for planes, bombs for planes, all the different equipment they needed to operate. And at the time, in 1922, when the first Electricity Supply Act was passed, electricity supply was placed under the control of the Ministry of Transport, because it was argued at the time that the railways were going to be fully electrified by 1926. I traditionally leave a pause for laughter at this point. I hope that's worked. And that because of this, because of the immense amount of power that would be needed by the railway networks, that almost 20% of electricity in the country would be required for the use of transportation services. The RAF hearing that the railways are going to be fully electrified naturally became concerned. Sort of, if there's a successful attack on power stations, our transport network goes down, we won't be able to operate anymore. So they get involved in looking at the design of the power stations, how to protect them, which incidentally then also turns into the we also know how to attack them guys. Although they're very quickly convinced that actually railway electrification is not going to be coming anytime soon, but they do get involved in arguing with the railway companies to, as they electrify, to all adopt the same system. So that they maintain an interest in this. The second reason for the RAF interest in the pylon network is that, unlike the Army, who had a view or had mixed views on the use of overhead cables, the RAF was adamantly against them. First of all, they believed that bomb damage would be more severe than it was. This is something you see time and time again with air forces during the 1920s, arguing essentially in Trenchard's view that the bomber will always get through, and that bomb damage will be so severe that it will force a country to surrender. We obviously know that this wasn't actually the case, and that they did severely overestimate the impact of aerial attack in this way. The other, and perhaps the more important view from the RAF, was that pylons were a hazard to its pilots, particularly its trainee pilots, who, if they needed to make an emergency landing, didn't want to have to navigate these extra aerial objects as they're coming in. So they actually requested that any new power lines should only be erected alongside roads, canals, railways, and other natural ground obstacles, which pilots in difficulty will naturally avoid. The Ministry of Transport actually agreed to this, and the RAF was given power to veto the construction of any overhead cables that didn't follow the lines of these identified obstacles. And this power was initially for 6 months, but continued throughout the 1930s and into the Second World War. So, as I've mentioned a couple of times, causing any significant damage to a power station through aerial attack was hugely problematic. And when you look at post-war analysis of British power stations and the British network, turns out that only 8% of all the reported faults during the Second World War could be attributed in any way to enemy action. 43.7 in total were attributed to defensive action, and most of these, as you can see from this period just in 1941, were due to damage by our own barrage balloons breaking loose. I kind of have to fit this story in because it's probably one of my favourite stories from my entire thesis. So this this experience led to what was to become one of the most successful attacks on power infrastructure that was carried out in the Second World War. But of course, it's hardly the best known, and I'll come to the reason for that very shortly. Normally, when you ask someone about attacks on power stations during the Second World War, the first thought that comes to their mind is Operation Chastise and the Dam Busters. And this is definitely the most well-known of all the attacks. Carefully planned attack using specialist equipment by specially trained flight crews. And it succeeded for a given value of succeeded. The most of the targeted dams were damaged and the hydroelectric power systems were destroyed. However, within 6 months, electrical power generation from those sites had been completely restored and the disruption from it was actually minimal. This isn't to minimize the loss of life because thousands of people died in these attacks, but in terms of the industrial impact, it was absolutely minor. And Air Chief Marshal Harris and Albert Speer, the head of the German industrial effort at the time, noted that this had been minimal. In both cases, it was actually an idea that actually maybe this should have been a more sustained operation rather than a one-off attack. And that's where a particular contrast to what became known as Operation Outward comes in. So in 1941, Marshal Owen Tudor Boyd, proper RAF name, as you can tell, was in command of RAF Balloon Command, and he noted that since the outbreak of the war, he'd received a series of complaints from electricity distributors regarding damage done by balloons which had broken free from their moorings, and suggested that advantage might be taken of this to impede and inconvenience the enemy. The idea wasn't picked up by the RAF. They didn't like it. I actually get to bring the Royal Navy back in at this point, or more specifically, the Women's Royal Navy Service. My wife was part of that for a brief while, is making happy noises in the background. So this was the only offensive operation carried out by the Wrens throughout the entirety of the war, and it made use of surplus weather balloons trailing piano wire, of all things. It cost an estimated £2 per balloon, including the hydrogen used to inflate them. And over the course of the war, it caused approximately £15 million worth of damage to German electrical infrastructure. Some of the post-war interviews and analysis indicate that the scale of the damage and disruption may actually be a lot higher than this. Because the damage, particularly to the low tension cables, was so severe and so frequent that they were completely unable to keep track of the number of incidents involved. Possibly the single most successful incident with this particular event was when a single £2 balloon struck a 110 kilovolt line near Leipzig, causing a circuit breaker to throw in Boland Power Station, putting over 250 megawatts of generating plant out of action permanently. By the end of the war, the Admiralty were really keen to publicise the success of this particular attack, and the operation in general, but the War Cabinet suppressed the results and suppressed all records of the operation deeming that it would be unwise to release details of a form of attack which had the potential to be employed against Britain. In the end, the women involved in the operation all received citations for having caused damage equivalent to the loss of a capital ship. In this case, this is going to be a battleship or an aircraft carrier, so around about £7 million worth of ship. So this was a fairly significant contribution, and one that you would have thought people might be quite pleased to share in this manner. But as we've already mentioned, not only the military, but the industrial infrastructure of Britain, the domestic life of Britain, was becoming to rely increasingly on access to electricity. So any potential disruption to this would be severe for the entire country. And the last thing you really want to do is go around giving people an idea for actually this would be a really, really successful way of disrupting our economy, disrupting our industrial capacity. So my general conclusions from this, and this is very general and spoke very specifically on the military aspects of it, which formed possibly one of the most minor parts of my thesis, but I don't get to talk about it very often, is that military involvement in electrical development can be traced back at least as far as the First World War, although as we can tell from the fact that the army had equipment left over from the Boer War, this interest had been in place further back. The military has formed a key component in the layout and composition of the existing grid network, and that includes the grid as it exists today, of which the basics were formed by 1936. So the RAF interest in where pylons should go was a significant part of the reason that the grid ended up in the shape it is today. Of course, it's not the only reason, and I would even say it's not the primary reason. It looks like economics and simply the fact that the Ministry of Transport already had permissions for the wayleaves and the necessary legal requests to actually erect pylons in those places. And I guess one of the final ones is that this is coming back to the threats to electrical suppliers or energy suppliers today, is that a lot of the time today, when you look at a news report on the threat to electrical systems, there is a huge focus on what are the cyber threats to the system, how are nuclear power stations or switchboards vulnerable to viruses. And this idea of a physical threat to the pylon networks, the power stations, seems to have been very much put on the back burner. And with the increase in availability of small drones, for example, or even in some cases that I've heard of, the children's helium balloons, the potential of damage to electrical infrastructure by these possibly slightly lower tech means is one that I think should possibly be looked into more seriously than the cyber threats that are currently the main focus of research in that area. So I think that's more or less me for this.